In this video, we are looking at activity 3C on Hess's law and enthalpy or formation. And so this first problem says the heat of combustion for the gases hydrogen, methane, and ethane are provided in the table below. Calculate the heat of reaction for the following reaction. So in the table, we are given the delta HF, which is the heat of formation for each substance. So heat of formation problems are really pretty simple. All we need to do is we need to take the sum of the delta HF values of the products, and then we need to subtract from that the sum of the delta HF values for the reactants. So we just have the sum of the products minus the sum of the reactants, and that will give us our overall enthalpy change for our reaction. So our products are the ones on the right side of our equation, so C2H6, and then H2. So we need to add those two values together, and then we'll subtract our reactants, which is CH4, and we have 2 of that CH4, so we're going to need to take 2 times the value for CH4. And so these is not a real equation, it's not really showing us any answers here, but I always just like to write out my products minus my reactants and multiply by my coefficients to remind myself that of what I'm going to have in my equation to make my sums. So looking up at our table, C2H6, I'm looking up my table, C2H6 has a value of negative 84 kilojoules per mole. So negative 84 kilojoules per mole for C2H6, and then we need to add H2, the value for H2, which looking at my chart is 0 kilojoules per mole. Kilojoules per mole. So those are my products. And then I need to subtract out my reactants. So I'm going to do 2 times whatever the value for CH4 is. And looking up here, my value for CH4 is negative 74.6 kilojoules per mole. Negative 74.6 kilojoules per mole. So now I have my whole problem set up, and as you might notice, there are a lot of negative signs in this problem. So I like, before I type this into my calculator, to go ahead and predict the sign of my answer and go ahead and simplify a little bit. So negative 84 plus 0, I know that's going to be negative 84 kilojoules per mole. And on the other side, I have minus a negative. So I know those two negatives are going to cancel out. So I'm going to end up with plus a positive number. Plus 2 times 74.6 kilojoules per mole. So if you are unsure of canceling negatives and positives and things like that, go ahead and type this whole thing into your calculator, but it's always a good idea to predict the sign of your answer so that you know if you have made a mistake. But just write out the whole problem, because that way if you get your answer wrong on the test, you can still receive partial credit for showing your work. So now I'm going to pull out my calculator here. I'll put it over here so we can hopefully see. Move the paper over a little bit. So I'm just going to type all this into my calculator. So when I put a negative value in, I need to use this negative sign down here. The minus sign will not give me the correct answer. So make sure you're using the correct sign. So negative 84. And then I don't need to put plus 0. And that's my whole first part. And then minus 2 times negative 74.6. I'm going to put my negative 74.6 in parentheses, and then close my 2 times that parentheses, hit enter, and I got 65.2. And that does make sense, because 2 times 74 is going to be close to 150, so negative 84 plus 150 is going to give me a positive number. So that does indeed make sense. The answer to my problem is 65.2, and my units, of course, are kilojoules per mole. Box that final answer in. So problem number 2 says determine the enthalpy change for the following reaction using the standard heat of formation data provided. So this problem even tells us that these are heats of formation, but if we didn't know that, we just look and see that it has delta HF, and so these are standard heats of formation. This little degree sign at the top indicates that these are standard. So we just need to do the sum of our products minus the sum of our reactants. So sum of the delta H values of the products minus the sum of the delta HF of the reactants. But you might notice that the equation here is not yet balanced, and so in order to know how many times to use the delta H of formation, we need to first balance our chemical equation. So I notice there's 2 sodiums here, only 1 here, so I'm going to put a 2 there. That gives me 2 hydroxide, and I'm going to rewrite this as HOH to make it easier to balance. So I can see there's only 1 hydroxide here, so I'll put a 2 there. And then I have 2 hydrogens, 1 sulfate, 1 sulfate, so otherwise I am balanced. So I'm going to fill in my 1s for everything else. So now I need to do the sum of my products. So my products are Na2SO4, and I only have 1 of those, so Na2SO4 is negative 1387.1 kilojoules per mole. And then I need to add in my other product, and I have 2 water molecules, so I'm going to do 2 times my value for H2O, negative 285.8 kilojoules per mole. Okay, so there are my products. Now I need to subtract out the sum of all my reactants. So I'm going to put a big old minus sign there to split those up. And in fact, I'm actually going to make these big brackets around my first section so it's easier to keep track of my values. Okay. And then I'm going to subtract all of my reactants. So I'll open up a new set of brackets. My first reactant is H2SO4, which I only have 1 of. H2SO4 is, the enthalpy value is negative 814 kilojoules per mole. And then my second reactant is sodium hydroxide, which I have 2 of. So I need to add that in, plus 2 times negative 425.8 kilojoules per mole. Okay, close that parenthesis, and then I need to close my brackets over here. So I could type all this into my calculator, but I like to simplify a little bit as I go. So I'm first going to do negative 1387.1 plus 2 times this value. So I'm going to, in my calculator, do 2 times negative 285.8, which gives me negative 571.6. Okay, so then I still have my first set of brackets, and then I'm still subtracting the other side, which is going to be negative 814 plus 2 times negative 425.8. And I do that. So I got negative 851.6. So that simplifies this a little bit and maybe makes it a little easier to follow along. Move the sheet up a little bit. Now I'm going to do each set of parentheses. So I'm going to take this previous value, negative 571.6, and then add that other value plus negative 1387.1. And I'm actually going to redo that because I forgot to close my parentheses, but it gave me the same answer, which is negative 1958.7. And then, of course, I need to subtract my second answer. So, negative 851 I've had before, plus negative 814. Now I got negative 1665.6. Now all that I have to do is do this answer minus that answer. So, let's move it over so you can see a little better, negative 1958.7 minus, open parentheses, negative 1665.6, and that gives me negative 293.1 kilojoules. And of course my units are actually kilojoules per mole. So there is my final answer. Just a lot of addition and subtraction here basically, and making sure that we pay attention to our negatives in this problem. Our next problem says ammonia reacts with oxygen to form nitrogen dioxide and steam as follows, and it gives us a nice balanced chemical equation. Given the following standard enthalpies, calculate the enthalpy of the reaction. And so this tells us that these are enthalpies of formation, so even though it doesn't specifically dictate it in the table, it's given up here. So we know that these are enthalpy of formation, so we need to do the sum of the products minus the sum of the reactants. Okay, so our products are NO2 and H2O, but we have 4 NO2s and we have 6 H2Os. So I'm going to go ahead and write that out so I don't forget to multiply by those things. So those are our products. And then we need to do minus our reactants, and we have 4 NH3s, 4 times NH3. And we have 7 oxygen, 7 times O2. Fill in some values. So we have 4 times the value of NO2, which is 33.2, plus 6 times the value for H2O, which is negative 241.8. So all that is our products, and then we need to subtract out the values for our reactants, which I'm going to have to write smaller. We're going to run off the page here. Let me just go ahead and move that over a little bit so we can keep seeing what we're doing. 4 times our value for NH3, which is negative 45.9. And then we just need to add in our value for O2. 7 times our value of O2, but O2's value is 0. So 7 times 0 is going to give us 0 there. So now we can start simplifying a little bit. If we do 4 times 33.2 in our calculator, we get 132.8 plus this next value, 6 times negative 241.8 in our calculator gives us negative 1450.8. I'll put that in parentheses since it's a negative value. Then we're going to be subtracting out these other values. 7 times 0 is going to give us 0, so we just need to do 4 times negative 45.9, which gives us negative 183.6, plus 0, of course. So now we have 132.8 plus a negative 1450.8. So that's the same as doing 132.8 minus 1450.8, and that gives us negative 1318 put together. And then we're doing minus a negative value, which changes to a plus 183.6. So if we do negative 1318 plus 183.6, that gives us a final answer of negative 1134.4 kilojoules. So now we can box that final answer in.